Hey guys, welcome back to my YouTube channel. So in this lecture, we are going to continue our discussion on the digital electronics subject. So in the number system, most of the majority basic concepts that we have covered. So today we will be starting with basic logic gates. So first thing that we are going to discuss today is the AND gate. So this is AND gate. So we know the logic of AND gate. So that will be the product of two things. So let me write a truth table first so that you guys will be able to get the thing. So this is how the truth table will look like. So A, B, which is two input AND gate, the output will be product of A and B. So this is two things. So 0, 0, 0, 1, 1, 0, 1, 1. So for combination, we can do it. So product of 0, 0 is 0. So 0, 1 is also 0. 1, 0 is also 0. So 1, 1 is the 1. So this is how the logic will looks. So the general representation of AND gate will be quite like this. So this will be A, B and AB. So this is how the logic gate will be represented diagrammatically. So the logic gate of AND will follow both commutative as well as associative property. So the thing AB which will be equal to BA, so we can state this as a commutative, and ABC which will also be equal to AB in the bracket of C. So the both commutative and associative property will work in the AND gate. So we can clearly state that this is one similar logic gates, one of the basic functionality logic gates. So let's see the diagrammatic insert circuit representation for the logic gate that is present in AND. So we will usually represent every gate in a systematic way, like how the external structure, like black box structure, we will maintain, but how the internal structure or how the internal connection is there, that we let's see in this diagram. So let me draw a internal structure, how that will look like. Okay, so this is the two input A and B which is connected. So this is plus VCC. So when we completed the digital electronics course and the analog electronics courses, you will be able to grasp all the concept. So for now, I will explain some basic criteria to make you understand all these things. So this is diode. So this is an PN junction diode which is connected P and N. So it is connected as NP. So this is another one diode. So any logic gate can be built using any type of circuits. So with using diode, with using transistor, with using CMOS, with using NMOS, PMOS, or transistor logic, or resistant transistor logic, any kind of things we can do. So in this one, for your understanding, I have just created a circuit with the normal diode. So this is the output Y. Okay. So let's take a truth table event and let's find out how the functions are working. Okay. So let's take the input A and B. So we need to apply different inputs, which will be 0, 0, 0, 1, 1, 0, and 1, 1. So this is diode D1 and the below diode is D2. This is RC, load capacitance. So D1, D2. So here the output Y. So when we apply 0 here, 0 and 0 is the input, and here plus VCC will be generally termed as positive 5. So here if you see, this is P terminal and this is N terminal. So P is connected to higher voltage and N is connected to lower voltage, that is 0. So means both the diode will be on. So N1 will D1 will also be on, D2 will also be on. So if that is the case, it is directly shorted to the input, any one of the input. As both the input is 0, the output will also be 0. So this is how the logic gate will work. So we are representing a diagram, like, so this kind of representation we are mentioning, like the internal structure will be like this only. So this structure will lie inside. So the VLSI engineers will take care of it. So these structures will be built inside this kind of logic. So this is what A, B and Y. This supply voltage that is triggered over the motherboard or any kind of logical circuits. So if we give A0 and B as 1, so if we give the input A0 and B as 1, then also what will happen? The diode D1 will be on. So diode D1 will be on, but diode D2 will be off, because this is also considered as higher voltage. But due to this resistance here, the voltage will be applied here, that's considered as something less than 5. Here 1 is considered as positive 5 voltage. Okay, so this diode 2 will be off condition. So here also the y is directly shorted to the 0, so the output will be 0. The same case here, where the difference is D1 will be off and D2 will be on, the same output will be 0. So if we take example, both the input are 1, then both the diode will be off. So this will also be off, this will also be off. Then this terminal will be directly connected to Y. So this both the diode will be off, but output Y will be 1 because of VCC. So this is how the internal structure of AND gate will looks like. This is how the internal structure of AND gate will look like. So let's see sum of unused input. So if we instead of giving some input to A and B, if we use the input as unused, then what will happen? Let's discuss that thing. So unused input in AND gate. So if we leave the input, any one of the input in AND gate as it is, then what will happen? There is many triggers, many kind of triggers that we can do. So in some case that will be considered as a 0. In some case that will be considered as 1. So for an example, if we are using 2 input AND gate, for an example, if this is a 2 input AND gate and this is our output, we are giving A1, we are giving A input here, and we are not giving another one terminal, we are not giving anything. So then what we have to do here? So this is one of the important question. Then what will be the output here? So we are having only one input to give for the 2 input logic gate, but the another one input, what we can do? There is 3 things we can do. One is connecting to enable input. We can connect that to enable input, which is nothing but VCC. So that is one thing, which is enable input means that is VCC. Second thing is we can connect to any used input, like any used input. We can loop it to any used input. Third thing is the floating input. Floating. We can just leave it floating, then it will consider as 1. So floating, but this floating is only possible in TT, transistor logic. In transistor logic only, the free input, unused input will be considered as 1. So unused input will be equal to 1. So this logic can be tried with these 3 input. Like we can connect to VCC, this is one thing, or we can connect the same thing to A. So we can do like this one. So this is also possible here. Or else we can leave it as it is floating. So if it is floating, then this is considered as 1. So this is A. So then output will be A. So here A into A is also A. So if we connect to VCC and all, then the output will also be A. So these are the 3 things that we can do if the unused input in any of the AND gate. So even if the multi-input AND gate is there, we can use any of these 3 methods to make it working properly. So I hope it is understood for you guys. So let's go for the second basic gate, that is OR gate. So similar to the structure that how the 2 input AND gate works, the same logic, but instead of multiplication we will add that inputs. So AB output will be A plus B. Here you can see the difference. Here we have mentioned the logic gate representation diagram is different. So the truth table will be quite different from the AND gate because we are adding the input instead of multiplying it. So here A, B, here A plus B. So here if any one of the input is greater than 1 or that is connected to VCC, the output will be 1. So 0 0 will be 0, 0 1 is 1, 1 0 is 1, 1 1 is also 1. So this is how the logic gate will work. Here also the commutative as well as associative property will work. All the basic gate will work for it. Associative property will work. Okay. So this is for the logic gate for this thing. So let me draw a diagrammatic representation like the internal logic structure how it is works in OR gate. So here we are connecting a resistance here and this will be connected to ground. So in OR we are connecting this to ground in OR gate. So this is what the output Y, and here we are connecting the diode in the P and N direct normal mode. So where we have connected reversely, right? So here we'll be connecting like this. So this will be the A and B output. So let's take the table and find out how the values will come here. So let me drag and drop here. So let me draw a table in order to understand the things properly. So this is A and B input, and this is the diode circuit output. So let's consider a thing. So here it's A, B, here it's D1, D2, and here it is Y output. So this is diode D1 and this is diode D2. So if we give output 0, 0, 0, 1, 1, 0 and 1, 1, then the output will be, so if we connect a 0 and 0 here, then if you see the positive terminal is much greater because it is connected to ground. So in many of the case we will consider this ground as a minus VCC. So we will consider that to be less than the positive terminal output. So even if we consider this as a 0, because of this resistance, the voltage at this level will be quite lower than this level. So we will be considering this diode to be, instead of considering this to act in a on condition, we will consider this to be in off condition. So this is also in off condition. So if we change the output, so if A is equal to 1 and B which is equal to 1, A is equal to 0 and B is equal to 1, then diode 1 will be in off condition, but diode 2 will be in on condition, because we know that here it is higher potential than here. So because here will be mostly considered as 0, so let's take this as a 0 itself. So here also 0. So here it is both the terminal are considered to be same. Because of the resistance effect, we will consider this to be thing, so that no current will flow here. So D1 will be off here. So in previous case also the same thing. So I missed to mention this one also. So if it is 0, 0, here also 0, there is no net change, so no current will flow in the circuit. So we are considering both the diode off in the previous case. So similarly, if we give 1, 0, then this will be in on and this will be in off. So whenever there is an input there, the diode will be on. So here both the diode will be on. So both the diode are off, then we can clearly see that there will be no current flowing, and this will be, the Y will be connected to this ground. So if both the diode are off, then Y will be connected to this terminal, this one. So this will be considered as on. This, any one of the terminal is on, that will be connected to the Y, so that will be on. So this here also, if any one is connected, that will be on. Here it is 0. I forgot to mention this. So here it will be connected to ground. So ground means it is considered as 0 because it is connected like this. So if any of the diode is on, that input will be directly shorted to output. So I hope the OR gate logic is understood for you guys. So from next class, we also will be starting with the other important gates like things. So here also the concept of unused input can be connected to enable input, or another, it can be connected to any of the used input or floating input. So similar to how we have discussed for AND gate, we can do that. So in the next lecture, we will be starting with NOT gate and other important basic gates. After that, we will be going to XOR and XNOR, some kind of important special functions logic also we can discuss. So like, share and subscribe the channel. So stay tuned for next lectures guys.